As an alternative to the reference counting, which actually collects garbage all of the time, garbage collection algorithms that we're going to talk about right now do exactly the opposite. They don't collect garbage at all. They just let it pile up. At some point in time, when somebody tries to allocate new memory and is told there is no more, so then the garbage collection algorithms actually kick in. Now, these are theoretical algorithms, and obviously the actual implementations are a bit different. And also, I might as well say right now, it doesn't have to wait until there's actually no more memory to allocate. It can be done in different ways, and we'll talk about that soon also. But as a general theoretical algorithm, that's actually the way it's done. So how does it work? Let us assume that each memory location or box, or however we called it, has an additional bit called the indicator bit. So let's assume, for example, this is our memory. I'm just, draw it as a, this is our memory. And we have what's called an indicator bit. So every one of these boxes has an indicator bit. Okay. And we could just draw it for all of them, but that's, So we have our indicator bit, which says whether it's garbage or not. Now, let's begin and assume that a whole bunch of boxes have been taken up with data. Let's just put data into them. So let's go put data into them. I don't know, 13, hello, and etc. X, Y, Z. Let's say A, B, W. I purposely skipped that one. M, R, Q, 1, 2, and 5. Okay, I just put data into them. Now, suppose that some of them actually became garbage. I don't know which ones, but let's just choose a whole bunch. Now, I purposely just skipped the one in the middle just to say it was never allocated. Okay, never taken. And let's just say a whole bunch of them became garbage. Let's suppose this one became garbage, and so did this one, and so did this one. Okay, they all became garbage. I don't really care which ones. And we'll leave some not garbage. Okay. Now, my assumption, obviously, like before, that they're all just linked together. It's not drawn like that. But let us begin. Once I decided to start with the actual reclaiming algorithm, and I'm talking about now an algorithm called mark and sweep. That's my algorithm, mark and sweep. So the first thing I do is I have one pass over the memory, and I just mark everything as garbage. I'm just going to mark all memories as garbage. Now, obviously, that's not always true. Some of them are garbage, some of them are not. Okay, notice I marked everything as garbage, which is true for some and not true for others. Now, step number 2 is you start from the runtime stack and you follow through from the runtime stack into the heap, and any memory location that you hit, you turn the indicator bit from garbage to not garbage. So for example, this one will turn into not garbage. So will this one, right? So will this one, and so will that one. Because all these guys I was able to access directly from, or indirectly from the runtime stack, right? So these guys are not garbage, and all the other ones are garbage, right? Okay. Now, that's pass number 2. Pass number 3 is we search the memory and we look for all the garbages and we put them into our free list. So we have our free list pointer, which is actually going to point at memory location, this one right there, right? And then we're going to start linking all the garbages. Notice the next one is not garbage, so this will link to that one, which will link to this one, right? Which will skip over this one and go and link to that one, which will skip to there. Notice I'm just filling up my free list, right? Notice that the empty one is also garbage. It hasn't been linked, right? And I'm linking into there, and there's my free list, and this is points to null. This points to null, right? So notice what I did. I had three passes. Pass number 1, I went and I marked everyone as garbage, whether it is or it isn't. Pass number two, I went and actually started at the one-time stack or globals, makes no difference, right? Or what's called what you might call as the live set, and I follow them through to the heap. Now it could very well be the one heap led me to the next heap, then led me to the next heap. It makes no difference. I followed them all through, and everyone that I met and I touched, I said, okay, it's reachable from the live set, and therefore it's not garbage. Now, all those that actually remained garbage when step two was finished are really garbage. They're inaccessible from anywhere from the live set. So round number three went and said, okay, let's collect them and create a new free list. And this is what's known as mark and sweep. That's the general mark and sweep algorithm.